Atoms. We have said that matter is made of atoms, but atoms are much too small to see with light, and until recently couldn't even be imaged with the strongest microscopes. Recently, using scanning tunneling microscopy, atoms can be imaged. But it isn't light doing the imaging as our eyes do, but electrons. So how do we know that atoms exist? How did we know before these new images? The Greek philosopher Democritus theorized that matter could be divided and divided until it reached the smallest particle. He called those indivisible bits atmos. Democritus and his teacher Leucippus observed that some things are obviously discrete, like these seagulls, whereas other things, like the beach from a distance, or water, look continuous. But if you look more closely at the beach, you can see that it is made up of individual grains of sand. Democritus and Leucippus reasoned that water, and all other matter that appeared continuous, was also made of invisible, individual parts. They theorized that all matter is discrete, not continuous. As natural philosophy became more what we would call scientific during the 18th century, with the application of careful experiments and measurements, Antoine Lavoisier began to apply these ideas to chemistry. Lavoisier's measurements of chemical reactions led him to state the law of conservation of mass, or matter. In a chemical reaction, matter cannot be created or destroyed, only changed in form. The mass of all products at the end of a reaction must be the same as the starting mass of the reactants. As more and more reactions were studied, applying careful measurements to the experiments, and as more elements and compounds were discovered and categorized, Joseph Louis Proust summarized these results in the law of constant composition, also known as the law of definite proportions. Specific compounds, no matter the source, always have the same mass ratio of component elements. So, for example, basic copper carbonate, no matter whether it is the mineral malachite, the patina on a copper statue or roof, or made in the lab, is always 63.6 parts copper, 40 parts oxygen, 6 parts carbon, and 1 part hydrogen by mass. If you combine these two laws, you find that any chemical reaction needs the proper mass ratio of starting materials, or there will be some unreacted material left over. Definite proportions, or constant composition, says substances will form compounds in specific proportions. And conservation of mass says that if you don't start with those proportions, something will be left over, since you have to end up with all the mass you started with, even if some of it didn't react. Conservation of mass and definite proportions are laws, observations that have been repeated over and over. They are not theories. They don't explain what is happening. They just state what is observed. In 1803, John Dalton proposed an explanation of these laws, a theory. Dalton's atomic theory of matter. If all matter is made of atoms, which are the smallest bit of an element, and which cannot be destroyed, then chemical reactions are simply the rearranging of these atoms in different combinations. Matter is not created or destroyed. The atoms are all still there, just in different arrangements. And compounds are specific combinations of atoms, so the elements combine in definite proportions. Much of Dalton's atomic theory still stands today. Only a few parts have been modified. No parts of his theory have been completely thrown out. So, for example, Dalton thought atoms were indivisible. We now know that there are subatomic particles. And he thought that all atoms of an element were exactly the same. We have since found that atoms of the same element can have different masses. So Dalton's atomic theory explains chemical reactions. Magnesium and oxygen react in specific mass ratios because the masses of magnesium and oxygen are different. The atoms rearrange to form the compound magnesium oxide, with one magnesium atom for each oxygen atom. If not enough oxygen is added, some magnesium will be left over. Dalton's studies and his theory led him to state another law, the law of multiple proportions. Some elements may combine in different ways to produce different compounds. For example, carbon can combine with oxygen in a mass ratio of 3:4 to form a toxic gas, or in a mass ratio of 3:8 to form a gas that we breathe out, or that results from the burning of wood or coal. So, while Dalton never saw an atom, he knew they existed, since that was the best explanation for the data.